This video will give you a brief demonstration of Azure DevOps and ARCAD working together. This is an ARCAD application, and this is an ARCAD metadata repository. It's a metadata repository. It has multiple layers, and it contains information about your information systems. Here's all the components that make up this business application, for example. This information is used for analysis and build purposes. Applications define environments, like development. A version is a change set. It's associated with an IBM I library. Today, we're using Azure DevOps to host our Git repository, and here you see the ARCAD application linked to that repository. This is Azure DevOps, and here is the Git repository being hosted by Azure DevOps. Within this Git repository is source from the IBM I. Notice that we're looking at a feature branch. A feature branch is a copy of the main branch, and it's used for development purposes. ARCAD's integration creates an associated version every time a branch is created within the Git repository. Remember, the version is an IBM I library. The components being changed are being checked out into this version. The checkout process is taking source from the branch in Git and bringing it to the IBM I library. We're doing this in RDI today, but 5250 is also supported. Here's the same set of components that we checked out in RDI. IBM I developers make changes and test the way they always have. Many different features can be worked on at once. In a feature release model, the features are merged into releases. The releases are then built and deployed. The ARCAD integration means there's really not much change for an IBM I developer. They check out, they double-click, they edit, they use the LPEX editor or 5250, they make their changes, and then they compile. They can see their background jobs. They're working in an IBM I library the way they always have. Nothing has really changed for the IBM I developer. When they're done, they need to tell Git that the changes have been made, and here is how they would perform that commit. This export process runs an ARCAD macro. It takes the changes from the IBM I library and it places them on the correct branch within the Git repository that's being hosted by Azure DevOps. Here you can see the changes that we just made on the IBM I. The next step is to get these changes into the proper release. In Azure DevOps, we'll create a pull request to merge the feature onto the release. We'll select the correct release and we'll perform the merge. This is a normal Git workflow. It's checking for conflicts, it's detected none, so now we can complete the merge. The merge updates the release branch within the Git repository. It can also trigger automated processes. This is the version associated with the branch where the merge was just done. Now, when this merge completed, an Azure pipeline could be triggered. The Azure pipeline triggered ARCAD Builder. ARCAD Builder is building the release automatically, and it's logging every step. This is a predefined build process that uses the ARCAD metadata repository to make it a smart build for the IBM I. Remember, this happened automatically. The source was placed in the release library. Compilations are performed in the correct order. It covers the change and all its dependencies. This is a pipeline, so it can also trigger deployment processes. For demonstration purposes, we'll do this manually today. We're creating a drops release. That's performing a drops import. A drops import is a predefined process that knows where to collect artifacts from. It internalizes those artifacts into a drops release. That drops release can then be deployed. It can contain both native and open components. Again, we're doing this manually today, but all of this could have been automatic. A drops deployment is also a predefined process. This is the Drop Studio. This is an import process. If you look within an import process, you can see what it's done. In this case, it's collecting artifacts. The artifacts that this import process collected were the contents of the release that we just worked on. We can now deploy that drops release. As stated, deployment is predefined. It defines targets and the process to follow to get to those targets. Using the Studio, if you'd like, you can access a log and see everything that was done. And you can also see all of those predefined steps here. In today's example, we're just deploying to the IBM I. Remember, this process can also deploy to Windows, Unix, Linux, any target needed. When the deployment is done, the components are in the correct place on the correct targets. And if any issues are detected, a complete rollback can be initiated from the Drop Studio. As you've seen, using Azure DevOps to host your Git repository is absolutely possible with ARCAD software. For more information, visit our website at www.arcadsoftware.com.